Welcome to the solution video of paper 22, June 2022, Cambridge International IGCSE Additional Math. What is in front of you is the question number 1. It says there's a curve and its equation is this, where x is greater than or equal to 0, and that makes sense because square root of a negative number is not possible. It has to be more than or equal to 0. Then they're asking us to find the exact value of y when x is 6. So substitute x equal to 6 and we'll get y. But the condition they have given is that the format should be a plus b square root c. That means no denominator. So let's substitute x equal to 6 first and see what it comes out to be. So 6 plus square root 6 over 3 plus square root 6. Now we have to get rid of the denominator. And best thing is that we rationalize the denominator by multiplying by the conjugate of it. It is 3 plus, so 3 minus will be the conjugate, and we will have to multiply up and down both. So effectively we are multiplying by 1. So if we multiply denominator with denominator, we will use this identity, a plus b, a minus b equal to a square minus b square. So it is in the format of a plus b, a minus b. So a square minus b square, 3 square minus square root 6 square will be the expansion of these two. But the numerators are different, so we'll have to do them one by one. 6 times 3 is 18. 6 times square root 6 is 6 square root 6 and negative because there's a negative here. 3 times square root 6 will be positive 3 square root 6. And square root 6 times square root 6 is square root 6 square like this. Here square root and square root square cancel and we are left with just 6. So we'll write 6 here. And now we'll simplify this. 18 minus 6. They are the complete numbers, integers, 12. Then we have minus 6 square root 6 plus 3 square root 6 will be minus 3 square root 6. That's the simplification of the numerator. 3 square is 9, denominator minus, we got is 6. So it will be 12 minus 3 square root 6 over 9 minus 6, 3. Since we don't want a denominator, we'll separate the numerator with denominator, each one with them. So we can do this. So this denominator became the denominator of both individually. So 12 divided by 3 is 4. 3 and 3 cancel, square root 6. And this is the format. B is not there, we can write 1 because if there is nothing, we can multiply it with 1. So this gives us the final answer, a equal to 4, b equal to negative 1, and c is not square root 6, complete 6. This is the solution of question number 1. Okay, question number 2. They have given a graph which is one absolute and one simple line graph, y equal to gx, y equal to absolute of x. In absolute, the negative part is reflected. We don't know which part was reflected, but we'll decide as we go ahead. Solve the inequality fx absolute is less than or equal to gx. Less than means the graph should be lower. This is the y value of absolute fx. This is the y value of gx. They have written both are y's, right? So the y values from here in this line and this line is lower than the gx here. So this is the one they are asking. What is the solution of this? Solution of any inequality is given in terms of the values of x. So let me undo this one first. Okay. So this is the x value somewhere here, which is between 1 and 2.5, and this is the x value. Let's call this x1 and x2. They are unknowns, but they are saying solve. We can't write that the x value is between x1 and x2. We have to find x1 and x2, and the problem is that we don't know the equations of fx and gx. So since it is a 5 marks worth question, we'll have to find the equations of the two first, and then we will go to the solution part. So let's write the equation of gx first because it is straight line. Okay, y equal to gx, and we know that the format for equation of a line is y equal to mx plus c. m is the gradient. So let's find the gradient of this straight line, and this is a point on this which is 0, -1. This is the y-intercept, and one more point will be this one, 1, 0. Right? Let's find the gradient with the help of this. The gradient is always y minus y1 over x2 minus x1. So in this case, let's say y2 is 0. 0 minus minus 1 over x is 1 minus 0 is 1. So we got gx equal to 1x, and c is the y-intercept. We have y-intercept with minus 1 with us, so minus 1. We can write it x equal x minus 1, y equal to x minus 1. This is the equation of gx. What about fx? Without absolute, let's find it. So we know this point on the absolute graph, and we know this point, this one is 0, 5, this one will be 2.50, and I'm assuming that this rest of the part where we don't know any point is the reflected one. It doesn't matter which one you assume. So this line actual was like this, but because of the absolute sign, the negative part got reflected, and that's why we got this shape. Let's find the gradient of the second one. It will be m equal to y2. Let's take y2. 5 is y2. 5 minus 0 divided by x2. 0 minus 2.5. So I've taken this point and this point, and what will we get? 5 over minus 2.5 minus 2. So fx equal to y equal to mx. Mx is minus 2x plus c. Now what is the y-intercept? 5, so plus 5. This is the equation of fx, and now we can solve the inequality they have given here. We'll put absolute signs around it and we'll get it. So minus 2x plus 5, right? Okay. Minus 2x plus 5, which is absolute, is less than equal to gx, x minus 1. This is what we have to solve. Whenever we have absolute sign, we can write it twice. We don't know what is inside this absolute, positive or negative. So that's why once we write it as normal equation, and mind it, I'm writing equation, not inequality now. There's a reason behind this. I'll just explain. Let me write this one first. So put a negative in front of this part or the right side part, doesn't matter. I usually put here because we are uncertain about this part. That's why I write it here. Why did I write equal sign? Because we know that definitely between these 2 points of intersection, the solution lies. So just I want to find points of intersection. I don't want to solve the inequality. Okay, I'll find point of intersection and I will give my answer between x1 and x2. This is the answer. Okay, so just equal sign. Let's try to solve this one first. 2x minus x equal to minus 5 minus 1 minus 3x equal to minus 6. So this gives us x equal to negative 6 over negative 3, which is positive 2. Does it make sense? It does make sense. Between 1 and 2.5, x1 is 2. Let's solve this one first. This one second rather. So because of this negative, the signs will change. 2x minus 5 equal to x minus 1. So 2x minus x equal to negative 1 plus 5. So 2x minus x is x equal to 4. And that also makes sense. This number is much more than 2.5, and which comes out to be 4. So x2 is 4. So we are sure that our graph of absolute is below the gx between x1 and x2, and that's why our solution will be that x is between 2 and 4 with equal sign, because our question has equal. They can be equal as well. Not only lower, it has to be equal also. So this becomes the final solution. Well, question number 3 says find the possible values of k for which this quadratic equation has real roots. So there are 3 possibilities of having roots. First of all, this possibility that there are no real roots. Then we can have one real root, or then we can have two real roots. 3 possibilities are there. Since the question says has real roots, that means they're talking about these two situations. One root, one real root, or two real roots. For one real root, the discriminant b square minus 4ac is equal to 0. And for two real roots, b square minus 4ac, same discriminant is greater than 0. So basically we'll combine the two and our situation becomes b square minus 4ac is greater than or equal to 0. That will ensure that it has real roots. Now, what is a, b and c? The coefficient of x square is a, this is b, and this constant is c. And that's what we'll substitute here and we'll get the answer. So k plus 5 is b square minus 4 times a is k and c is negative 4, and we must ensure that it is greater than or equal to 0. So if we open this one according to this identity, a plus b square is equal to a square plus b square plus 2ab, it will get a square plus b square plus 2ab, and then we'll get plus because of these two negatives, 16, 4 times 4, 16k. Alright, so let's simplify this now. K square plus 25 plus 10k plus 16k is greater than equal to 0. Let's continue it here. It becomes k square, then 10k and 16k, 26k plus 25 is greater than equal to 0. So now, since this is a quadratic expression on the left side, let's factor this to find roots. And I will do what? I will write k square as k squared plus 26. I will write as 25 plus k, then 25 here and greater than equal to 0. Factor this k plus 25 plus 1, k plus 25. Alright, so two factors we get are k plus 1, k plus 25. Okay, so let's find the roots because of this. For roots, we equate them equal to 0, not inequality. Never use inequality in roots because that will give you wrong answer. So we'll get the roots. K equal to negative 25. Once we have the roots, the best thing is that draw a number line. Write the smaller root here, which is negative 25 in this case, the bigger root here. And since k is positive here, can you see this k is positive? That means that this graph will, if we draw a graph for k, it will be something like this. This is k and this is the value, this one is the value, which is this whole thing. It is the condition given that it should be equal to or greater than 0. Where is it equal to or greater than 0? It is in this area. The value of the whole inequality is greater than or equal to 0 here and here. It is above 0 mark, right? So this becomes our answer. The first one is because they are asking the value of k. K is this number line. So first area where the whole expression value is greater than or equal to 0 is less than negative 25, equal to also. They said equal to as well 0, right? So this is the area where the expression's value is greater than or equal to 0. The second one is here, k is less than, rather not less than, greater than or equal to negative 1. This particular area, the value of the inequality is greater than or equal to 0. So these two become our two solutions, two values of k. Okay, let's proceed to the next one. Variables x and y are related by this thing. Where x is greater than 0, that makes sense because it can't be 0. If 1 over 0 is there, it is undefined, and they're saying there shouldn't be any negative value. Use differentiation to find the approximate change in x when y increases from 4 by a small amount. Okay, so what they say that y is 4 and it increases delta y, small change is 0.5. 0, 1. We should know here that for small change, dy over dx is equal to delta y over delta x. That's what we write here. So delta y they have given as 0.01. So let's find the differentiation first and then we'll equate to this. So we have to differentiate this main equation. So dy over dx, differentiation of 1 will be 0. So no need to write it. Differentiation of 2 over x. Let me write here. 2 over x can be written as 2x to the power minus 1. And now if I differentiate this, this minus 1 goes and comes in front, multiplies with 2. We get minus 2 and then this exponent goes down by 1. So we get minus 2x to the power minus 2 or minus 2 over x square. That is the first differentiation part, minus 2 over x square. So this was 0, this is done. Now this, we'll write this as x to the power minus 2. So minus 2 will come in front for if we differentiate this, minus 2 comes in front and the exponent goes down by 1, we get minus 2 over x cube. So we'll get minus 2 over x cube. Now for small change, dy over dx becomes delta y over delta x equal to, let's take minus 2 common from here. So we are left with 1 over x square here and 1 over x cube here. Alright, they have given delta y, the change is 0.01, so 0.01 over delta x equal to minus 2, 1 over x is not known to us, y is known to us but not x. So we'll have to find x. How can we find x? We have the relationship between y and x here. So we'll use this. In place of y, let's put 4 equal to 1 plus 2 over x plus 1 over x square. Okay, we want to find x. So the right side has denominators. Let's get rid of those denominators by multiplying the whole equation by x square. So how did I choose x square? Because that was the LCM of x and x square. Equal to x square plus 2 over x over multiply by x square will be just 2x. Then 1 over x square times x square cancel, just 1 is left. Okay. Now this becomes a quadratic equation. If I put everything to the left side, it will be 4x square minus x square. 3x square minus 2x minus 1 equal to 0. And just like the previous part, previous equation, I can factor this to get roots of this one. 3x square minus 3x plus x minus 1 equal to 0. Take 3x common here, x minus 1 plus 1, x minus 1, x minus 1 is common, 3x plus 1. Alright, so x has two values. First one, x minus 1 equal to 0, which gives us x equal to 1. This gives us 3x plus 1 equal to 0, 3x equal to negative 1, x equal to negative 1 over 3. As far as I remember, in the question they had given x is greater than 0. Can you see here? That means the negative 1 is rejected. We can't accept this answer because x is not less than 0. So x equal to 1 is the only possibility, and we'll go back to our question where we left it, 1 square, because x equal to 1 we are accepted over 1 cube. Okay, 0.01 over delta x is minus 2 times, this is 1 whole, 1 over 1 square, 1 over 1 cube, 1 plus 1 is 2. Okay, so it becomes 0.01 over delta x equal to negative 4. So they can switch their places because of the cross multiplication. So 0.01 over negative 4 equal to delta x, that's what they wanted, and it will be negative 0.0025. This will be delta x. Negative means it's decreasing. As x is increasing, y is increasing, right? Y is increasing. x is decreasing. That's what it means. Let's move on to question number 5, which says that we have to solve this equation. And if we observe carefully this equation, we can see that all the numbers involved are power of 5. 625 is 5 to the power 4. 125 is equal to 5 cube, and we have a 5 on the right side. So that will help us to solve this. So what will I do? I will convert 625 into 5 to the power 4, and further it is x cube minus 1 over 2 to this, right? When we have power and another power over it, they multiply, and that's what we're going to do in next step. First, let me write denominator 5 cube and 5 cube to the power x cube, right? I have to put a bracket here and x cube here. Okay, and then we have equal to 5. Now what does it become? 5 to the power, let's if they multiply 4 and 2, this thing multiply 2 and 4 will cancel out. This will cancel with this, so we'll be left with 2x cube minus 2. Okay, 2 multiplied by x cube, 2 multiplied by minus 1, there is no 2 anymore, so that's the numerator. What about the denominator? It will become 5 and 3x cube, they multiply, equal to 5. Alright, since these two parts are dividing and they have same base, we can subtract the exponents. That is what the exponential law says. So 2x cube minus 2 minus 3x cube. This minus 3x cube is subtracted from the numerator, equal to 5, and let me write pi to the power 1. It is the same thing. So 2x cube minus 3x cube is minus x cube. 5 minus x cube minus 2 equal to 5 to the power 1. Since the bases are same, now we can equate the powers. So minus x cube minus 2 is equal to 1. And now it becomes a simple equation. We'll bring this minus 2 to the right side. Minus x cube equal to 1 plus 2. Yeah. So now x cube equal to 1 plus 2 is 3, and because of this negative I will transfer it to the right side, and to find x we'll cube root both sides. So x comes out to be cube root of minus 3. They're saying solve the equation, and they've not said whether we have to express in decimal or something. You can leave your answer like this or use your calculator to find the value of x. That's what I'm going to do now. When I used mine, I got x equal to negative 1.44. This is the solution after 2 decimal places. Okay, let's go to the next part. It says on the axis, there is an axis here. Sketch the graph of this function showing the values of any intercepts with coordinate axis. Alright, since it's exponential, you should know that the exponential graph looks like this, right? But suppose you forget during exams, so what you can do, that you can make a table. It will take more time, you have to spend more time on this, but this is the way you can do it. Take some negative numbers, take some positive numbers, say minus 5 till 5, okay, and put this x value minus 5, minus 4, minus 3 and so on in place of this x, and you will get y values for each one. If you join those values, you will get a graph. But what I'm going to do, I'm going to do with the help of the knowledge we have gained during this year. So this is the equation. We always focus on the basic, what is the function? E to power x is the basic function, and the graph of basic function is something like this. Rather, I've made it a little steeper. Let me undo this and draw it a little shallower. Okay. Every exponential graph, basic exponential graph, passes through 1 on y-axis. Okay. All right. So now this 4 will make the y value 4 times higher. That means this graph will become very steep because of 4. This is the effect of this 4. Always, because it's multiplying with the e to power x, it makes the y value very high as compared to the original one, and y-intercept will not remain 1 anymore. Let's say x is 0 here, right? At here x is 0, so we can put e to power 0 plus 3. When x is 0, what is the value? E to power 0 is 1. 4 times 1 is 4 plus 3, 7. It will pass through 7 now. Okay, so the shape was already changed and the intercept is 7 now. Now this was the asymptote. This x-axis is called asymptote, which will never be touched by the graph, right? It's coming near and near to this. What will be the value of this new asymptote with this plus 3? So just keep in mind, if y becomes 0, so let's make y equal to 0. Okay, though it will not be 0, right? It becomes 4 e to power x plus 3, right? And so we knew originally e to power x, that asymptote was 0. 4 times that 0 will become 4. 4 times 0 will be 0, and 0 plus 3 will be 3. So what happened? The one which was the asymptote earlier goes up and becomes 3. 3 will be the new asymptote. So if I say that, suppose this is 3, this becomes the new asymptote. Since the graph has become little clumsy here, so I will draw the final one. Final one will be that 3 is the asymptote, 7 is the y-intercept, and the graph will have same this steepness after this. So these blue colored graphs are not needed, just this pink color will be the final graph, and you can erase the rest of them. This is just to give you an idea. If this is not understood, the best way is spend some more time and make a table. You'll get the graph. Okay, let's move on to the next question, which is number 6, part A, which says, in this question, I is a unit vector due east. Due east means it's going towards east, and east is this way, I. Okay, and j is a unit vector due north. It is going towards north. That is j. A cyclist rides at a speed, okay, not velocity, of 4 meter per second on a bearing of 015 degrees. Okay, so if I draw north from somewhere, so this is north. From this point, it is going at a bearing of 15 degrees. I've drawn a little more than 15, but it's okay, so that it becomes cleaner. All right, write the velocity vector now. Write it as a vector in the form of xi plus yj. So this is the resultant, which is the magnitude is 4. 4. Okay, so this will be a resultant of some I in this direction. From the head of I will go up and it will become j. So they are saying show it in form of xi and yj. This is x and this is y. And that's how the resultant of 4, which is the speed, will be achieved in this bearing, straight bearing. Okay, so we have to find x and y basically. So this is 15 degrees, so this will be 75 degrees, because we know that this direction and that direction make an angle of 90 degrees, right? So let's find x first. X is the adjacent side of 75 degrees. So cos will be used. Cos 75 degrees equal to x divided by hypotenuse is 4. So cross multiply, x is equal to 4 cos 75 degrees. And if I want to evaluate this, I can use my calculator and I get square root 6 minus square root 2. That is the value of x. And they have not specified whether we have to give exact or decimal. So we can convert it to decimal also. In decimal, it will be 1.035. So we can write 1.04. Let's talk about y. Y is opposite to 75 degrees. So we will use sine 75 degrees equal to opposite over hypotenuse. Cross multiply again. Y becomes 4 sine 75 degrees. And just like the previous one, it will be square root 6 plus square root 2, or in decimals 3.86. So they said in the form of this we have to write, so you have two options now. We can write square root 6 minus square root 2I and plus square root 6 minus plus square root 2j, or if you want to write in decimals, it will be 1.04I plus 3.86j. That's the format. Okay, what's next? A vector of magnitude 6 on a bearing of 300 degrees. So let me show them with a direction now. This time we need something. Okay, this is, suppose this is the starting point and we have to go on a bearing of 300 degrees. Okay, so from north it is 90, then 180, then 270. That means we have to go in fourth quadrant after this, counting from north. So it will be this way. So this will be 270 plus 30, 300, right? This is the direction from starting from here. Okay, we reached here. Is added to. Okay, we can add on the head of this, like in previous part I told you that x, from the head of x we add y, correct? And that's why we got this resultant. Here they're saying from this we can add another vector, magnitude is 2. So this is magnitude 6, and from the head again we will draw a north here, and bearing has to be 230 degrees and magnitude is 2. So it is 90, 180 and 230. That means it will be somewhere going this way. This will be 2 for 230 will be 50. That means this will be 40. Okay. So one vector added to this. It is also possible that I would have drawn this vector first and added this one later. That is the same, we'll get the same result. There is no difference between the two cases. Okay. Now, and to give vector v, the resultant of these two is vector v. So vector v will be starting from the tail of the first and ending here. This is vector v. Okay. So we have to find the magnitude and bearing of v. So magnitude we can find here. Let's draw this triangle again. This is v, this is 6, this is 2, and the angle here is 50, and this one is how much? Okay, this is 30, so this is going to be 30, so that means this is 60. So 50 plus 60 will be 110 is the angle between them. And we can find the magnitude now. Let's use cosine rule for this. Cosine rule is a square equal to b square plus c square minus 2bc cos a. This angle must be opposite to this. So since our v is unknown, we will use here v square equal to, the other two sides are 2 square plus 6 square minus 2 times 6, and the angle opposite to V is 110 degrees now. Yeah, we know this is 110 and we can find it now. Let's try. Rather, let's do it straight away. V will be square root because we have to square root both sides to get V. So this will be 4, this will be 36, 40 minus 4 times 6 is 24 cos 110 degrees is 6.94. Is just a vector unit. Alright, they also want bearing of V. Here this V looks like to be same line as this horizontal line. No, it is not. It is something like this. Let me magnify this. Again, the same thing. Okay, this looks better. This is 2, this is 6, and the horizontal line is somewhere like this. So let's find this angle first, okay, and let's see if it is more than 30 or less than 30, then we will decide. So how to find this angle? Let me call this as point O, this as point A, and this as point B, so that I can find this angle, and I will use sine rule for this. Sine rule says what? Let me write here, sine A over A equal to sine B over B equal to sine C over C, and that's what I'm going to use here. We know this is 110 degrees and we just found this as 6.94. Okay, so sine, this angle we need to find, yeah, this one. So let's call it sine O. It's not sine 0, okay. Sine O over what is the magnitude of the line opposite to it, 2, equal to sine 110, and the line opposite to 110 is 6.94. Okay, so sine O, let's write here. Sine O, this cross multiplies here, is equal to 2 sine 110 over 6.94. And now I can straight away find the angle O. O will be sine inverse 2 sine 110 degrees over 6.94. Okay, let me use my calculator, and my calculator gives me 15.71. Let's call it 7 degrees. Okay, so yeah, this line, my assumption is wrong. It is not below this line, it is above this line, 15.7. This is the angle, this angle. Okay, V is actually in this direction, because can you see 2 I have drawn much longer than 6. That's why this kind of drawing came. So let me point it out. This is actual V, and this is 2 up to here. This is V, and we found this angle is 15.71. That means, let me draw the varying number. Okay, so my bearing starts from north. Okay, it is 90, 180, and 270 is already there. Now we have a line above this. Let's find this angle above that line. So it will be 30 minus 15.7 will be 14.3 degrees. This angle here is 14.3. So the bearing of V is 270 already there plus 14.3. That comes out to be 284.3 degrees bearing. This is the bearing. Moving on, question number 7 says differentiate this particular function with respect to x. Straightforward, no a part, b part, this is the only one. And I don't think it will create some trouble for us. So since it's a rational expression, rational function, so we will use a quotient rule for this. Rule. L. Okay, so as far as you may be remembering, this is u prime v minus u v prime. This is the differentiation if your function is y equal to u over v. So e to the power 4x tan x is u and ln x is v. So we will use this one. So first the denominator will be squared. So ln x will be squared. Please keep in mind ln x whole square and ln x square are the different things. It is the whole thing is being squared is not same as this, so they are different things, so we can't go beyond this. We'll have to keep it. All right, next u prime, that means we have to differentiate the numerator. Okay, so since there are two parts in numerator which have a variable in them, so we will use product rule in them. So u prime goes like this. So let me, because it will be a little longer, so I will do this. Okay, so I will differentiate e to the power 4x first. So e to the power 4x multiplied by 4. Yeah, differentiation of the exponent is multiplied further. Tan x is untouched, plus. Okay, in this time I will keep e to the power 4x same, but I will differentiate tan x secant square x. So I have done u prime. I have to multiply this with v. So let me move it little down so that I have some space. Okay, so v is the denominator, which is ln x, then minus u. So I have to write u first. So u is the numerator, e to the power 4x tan x. Now v prime, I will differentiate the denominator. So denominator ln x, its differentiation will be 1 over x. Okay, this is going to challenge us because we have a denominator here. To take care of this, let's do one thing. Let me multiply the first also by x over x, which is 1, correct? So that both of them have x as denominator. So I can write like this, whole over x. Yeah, and what are we left with? I will open this bracket also. This x will multiply with everyone, x e to the power 4x, and then we have 4, so 4 I will write here, tan x, plus again x e to the power 4x secant square x, and we have ln x multiplying with both, so I'll multiply ln x here and I'll multiply ln x here as well. Okay, there is no b part, otherwise this was not needed to be simplified further. Okay, here it will be e to the power 4x tan x, and that x is under both of them now, divided by ln x square. It looks a little complicated, so this x, because it's a denominator of the numerator, it can be multiplied with denominator itself. So our new denominator will be x ln x to the square. And now we can see if we can somehow, yes, e to the power 4x is here, e to the power 4x, e to the power 4x can be taken common. Okay, we are left with 4x ln x tan x, yeah? Here, x secant square x and ln x also, minus tan x. This is what we can have the simplest form, and we will stop here. Next question, number 8. The function f is defined as this. This is square here. Okay, and x is between 2 and 4 radians. Okay, find the x coordinate of the stationary point. Coordinate, not s, because in this trigonometric function, there are so many stationary points. So they're saying coordinate of stationary point. That means we expect there will be only one stationary point between 2 and 4. Let's see. So first, to find stationary point, we should know dy over dx or f prime x in this case. We'll differentiate this and make it equal to 0, because at stationary point, the tangent is a horizontal line whose gradient is 0. and that's what we're going to do. This is the gradient, the differentiation. I will make it equal to 0. Let's focus on this one first. This 2 will come and multiply with 3 becomes 6, and the exponent of sine goes down by 1, so which is 1 now. But further we have to multiply by the differentiation of the base of the power, which is sine x, and differentiation of sine x is positive cos x. Minus 2 is 2, it's a constant, will just differentiate cos x, which is minus sine x. Okay, and this has to be equal to 0 for stationary point. So do we have something common? Yes, sine x is here and here. So 2 also can be taken common, so which will be equal to 2 sine x taken common, 3 from here and cos x here. 2 is already out, sine is already out, and this negative is going to give us positive, and nothing left, 1 equal to 0. Now it is already factored. That was the purpose of factoring, that so that we get two answers from this. So first one is 2 sine x equal to 0, and this gives us 3 cos x plus 1 equal to 0. So here sine x equal to 0, because 0 divided by 2 is 0. So x will be sine inverse 0. Alright. So if we look at the graph of a sine function, it is something like this. We know this is pi 3.14, this is 6.28, 2 pi, and this is 0. We want to see if between 2 and 4, is it 0? Yes, it is 0 at 3.14. So this will give us answer x equal to 3.14, which is pi. Moving on to this one, where 3 cos x will be equal to negative 1 cos x equal to negative 1 over 3. So x will be cos inverse 1 over 3, negative 1 over 3. So since it is negative, cos will be negative in this quadrant and this quadrant. Here we don't use a graph like this, because graph is for 0, 1 and minus 1 only, because that makes it clear through the graph. But here we will use quadrants. So cos inverse positive 1 over 3 we will find out, because negative has given us quadrants. So let's find this angle by cos inverse 1 over 3. I got 1.23. So I'll write 1.23 here as well. So our next answer, let's call it x1. x2 will be pi minus 1.23, because this is the angle we want up to here from 0. So which is 1.91. Okay, it is not between 2 and 4, so reject this answer. Next, x3, third answer will be pi plus 1.23, and that will be how much? 4.31437. Again, it is more than 4. We want answer between 2 and 4 only, so this is also rejected. So this part, only this is the answer from part A. Then fx equal to 1 minus 3 cos x. Okay, so fx equal to, fx is what? Let's see fx. It is 3 sine square x minus 2 cos x equal to 1 minus 3 cos x. Okay, so let's convert this into a quadratic equation, but this is cos x, this is cos x, this is not cos x, so we will use identity where sine square x is 1 minus cos square x, so that we have everything in terms of cos. Minus 2 cos x minus 1, this one, and this will be plus 3 cos x equal to 0. And let's open the brackets. It becomes 3 minus 3 cos square x minus, okay, minus 2 cos x plus cos x is just plus cos x, right? Minus 1 equal to 0. And let's rearrange this. 3 cos square x will be the first, then cos x, and then minus 1 plus 3 will be plus 2 equal to 0. And we have to solve this. For that, let's assume cos x is equal to some alphabet, say p. Okay, so minus 3p square plus p plus 2 equal to 0, and I will factor it as usual. I have done in previous questions. In this video I will factor this. So minus 3p square, 3 times 2 is 6, so plus 3p minus 2p plus 2 equal to 0. Let me take minus 3p common here, so we'll be left with p minus 1 because minus is out, and let's take minus 2 common from here. It will be p minus 1. So the factors are p minus 1 1 and minus 3p minus 2 equal to 0. This gives us p equal to 1. This will give us minus 3p minus 2 equal to 0. Minus 3p equal to positive 2, p equal to minus 2 over 3. But p was my creation. So what will we do? We will just write them in terms of cos now, because cos x was p. So cos x equal to 1 is our first equation, and cos x equal to minus 2 over 3 is our second equation. Alright, again it is 1. In case of 0, 1 and minus 1, we should use graphs. This is cos graph again. Cos x is 1, where here and here. This is 0 and this is full 2 pi, which is 6.28. Is it between 2 and 4? No. That means this has no solution for us, because there is no one value of cos x between 2 and 3. Let's do this. Cos x equal to minus 2 over 3. Okay, minus 2 over 3 will be 0.6 somewhere here and here. That seems to be within 2 and 3. So let's do it. So we'll use quadrants this time. Cos is negative here and here. So this angle we have to find. We'll find it now. Cos x, x equal to cos inverse positive 2 over 3. I'm not using negative anymore, because negative I'll use in quadrants. So let me use my calculator to find what is cos inverse 2 over 3. By the time I use my calculator, I would request you to subscribe to my channel, like this video, share with your friends, and it goes a lot of effort to solve such papers which don't have any marking scheme. So I would request you to subscribe to my channel as soon as possible. Hit that red button to subscribe and bell icon. If I upload any video, you'll get the notification for that. Alright, when I use my calculator, I got 0.841 here, so I will write 0.841 here as well. So we have two solutions. First solution, x1 will be, this is pi, so it will be pi minus 0.841, because we measure our angles from 0 degrees to the line we draw, this one. And if this is pi, this line is this angle less than pi. So that's what we are going to do here. So if I put my calculator, it becomes 2.3 radians. What was the second answer? It will be in third quadrant, where cos is negative, pi plus 0.841. So it will be 3.98, and they said that they want answer between 2 and 4, right? Yes, it was 2 and 4, because this applies to B part also. So our answer will be 2.3 radians and 3.98, which are absolutely between 2 and 4. So these are the two answers. Question 9 is about circular measure, where they have given a diagram on this right side, and they have given all the details here, which are usual ones in the case when the area of the sector OPQ, okay, this one, area of the sector OPQ is equal to the area of the shaded region, this one. Show that tan phi is equal to 2 phi. Alright, so since these two are equal areas, so if I call it say area P, and this will be area P, That means that area of kite OPTQ will be 2p, isn't it? Because both of them are part of the kite, right? So let's find P first. P, because we know easily that the area of the sector is easy to find out, so we'll take P equal to area of the sector. Area of the sector, and the sector is OPQ. Okay, and what is that area? We know the formula for area of a sector is half r square theta. So it will be half, r in this case is a, so a square, and theta is the angle it is subtending, this sector is subtending on the center is 2 phi, so 2 phi. 2 and 2 cancel, it becomes a square phi, right? So the area of the kite is 2 times a square phi. This is what we'll write. This is 2 times a square phi. Now, what is the area of kite OPTQ? OPTQ, if you remember, this is a tangent. This will be a right angle triangle in that case, because radius and tangent always make a 90-degree angle on the point where they meet. And this is what I will use. I will find the area of this one triangle and multiply by 2. It will become the area of the kite. Okay, so let me make it a little cleaner. Okay, so I'm finding the area of this triangle OPT. So it will be 2 times the area of triangle OPT. And we know the area of a triangle is half base times height. So if this is 90-degree, I'll take A is the base, this line as the base, OP is the base. So let me write here half times OP, and height will obviously be PT. This will give me the area of angle OPT. So OP is already known to us, it is the radius, which is A. PT, for PT, let's redraw this triangle. This is P, this is T, this is O, and this angle will be just phi, because it is 2 phi whole, half of it will be just phi, and according to this right angle triangle, tan phi will be opposite PT over OP adjacent. So tan phi equal to PT, we want to know, OP we know, so PT comes out to be A tan phi. And that's what we're going to write here in our main equation here. 2 times area of OPT is half, base is A, let me write here also, A tan phi, this is what we got as PT, right? OP was A, PT we got as this one. So A times A again tan phi equal to 2A square phi. So can we cancel? Yeah, we can cancel this 2 and 2. It becomes A square tan phi equal to 2A square phi. Let's divide both sides by A square so that we get rid of A square. Both sides gone. Tan phi is equal to 2 phi, and that's what was the requirement. Tan phi equal to 2 phi, we just showed it. Alright, let's go to the second part, which is in case where the perimeter of the sector OPQ, same sector, okay, is equal to the half of the perimeter of the shaded region, this one, find an expression for tan phi in terms of phi. Okay, so first the perimeter of the sector OPQ. So perimeter of OPQ is half of perimeter of a shaded region. So perimeter of OPQ will be what? This line, which is radius A, and this line which is also radius A plus the arc, this PQ. Okay, and arc is, what is the formula for arc? R theta, radius times the angle in radians. So R is radius A, theta is 2 phi. The one it is subtending on the center is 2 phi. So it becomes A square, which is 2A plus 2A phi. We can take 2A common from this, 1 plus phi. This is what we can write here on the left side. 2A 1 plus phi is the perimeter of OPQ. Now half of the shaded region. First we'll find shaded region only. Perimeter of shaded region. Okay, let's go back. Shaded region will have this arc, okay, which is OP. So OP, not OP, PQ. And PQ arc is already known to us. 2AQ, we just got it already. 2A phi rather, not Q. Okay, plus. And we also found this side, this PT side already here, A tan phi, and this will also be A tan phi because the tangent from same point to the circle are they're equal. So we will write 2 times A tan phi. There are two of them. Yeah. This is the shaded one. So we will write here half, and then the shaded perimeter we just got 2A phi plus 2A tan phi. So 2A is common here as well. So we can take 2A common there also. 1 plus phi on the left side. Half times 2A taken common again. So we are left with what? Phi plus tan phi. Okay. So 2A is in both. So let's divide both sides by 2A here and 2A here. They're gone. A is gotten rid of. This 2 will multiply here. So 2 plus 2 phi. And here we're left with phi plus tan phi. They want tan phi in terms of phi, and that's what we're going to do now. Tan phi will stay, keep it here, tan phi. And here we get what? 2 plus 2 phi minus phi equal to this, and 2 plus phi equal to tan phi. This is our relation, tan phi in terms of phi. Bring on the next question, number 10. A GP has first term A. Okay, so first term A1 is actually A. The common difference is R, so R is R, where R is greater than 0. Alright, the second term of the GP is 8. Second term is 8. The sum of the third and fourth term is 160. So we know that AN is first term multiplied by R to the power n minus 1. So let's write this one, the sum of third term. So third term will be A, because A is A, R to the power 3 minus 1. This will be the third term, A3. So basically A3 plus A4 is equal to 160. That's what they're trying to say here. So I wrote A3 just now. Plus A4 will be A R to the power 4 minus 1 is 160. So it becomes AR square plus AR cube equal to 160. Let's take AR square common here. We are left with 1 plus just R here equal to 160. Now we have to arrive at this expression. That means A must go. And how can A go? With the help of this one. So A2, which will be AR2 minus 1, is 8. So 2 minus 1 is 1. So AR is equal to A. And I want R, I want to get rid of A. So I'll isolate A here. A is 8 over R. This will help us me to get rid of A. So in place of this A, I will write 8 over R. Then we had R square, 1 plus r equal to 160. 1 of this r will cancel with 1 r. So 8r 1 plus r equal to 160. Divide both sides by 8 so that this 8 goes. And finally we can write here r times 1 is r times r is r square equal to 20. And if we rearrange it, it becomes r square plus r minus 20 equal to 0, the relationship they wanted. Find the value of a. Okay, let's find the value of a. Let's find the value of r first by solving this equation. R square plus r minus 20. So I will factor this just like I've been doing in previous parts, some of the questions. So I will write 5r minus 4r because 5 times 4 is 20 and minus 20 equal to 0. So r taken common, r plus 5 minus 4, r plus 5 equal to 0, r plus 5, r minus 4 equal to 0. This gives me r equal to negative 5. This gives r equal to positive 4. They said r is greater than 0 and it is not possible to be a negative r, so we will reject this answer. This is the answer. But the question was find a, not r. But we know that a is 8 over r, which will be 8 over 4 now. This is our answer for r. So a is 2. Got it. What about B part? An AP has first term P and common difference are 2. Okay, AP. So first term is P, common difference is 2. The qth term, okay, qth term AQ equal to 14. So we should know the formula for nth term of any AP, which is the first term A1 plus n minus 1 D. So let's use that one here. AQ equal to 14, which will be equal to the first term P, rather this is P here, right? So let's write P. First term P plus AQ minus 1 because it is AQ and common difference is given as 2. So let's open this. 14 equal to P plus 2Q minus 2. Okay, so let's rearrange it. Bring this 2 here. 14 plus 2 and let's bring 2Q here. Minus 2Q equal to P. We could have brought P also this way, but we would have to divide by 2 later on. So I'm doing this. I hope this is helpful. 16 minus 2Q equal to P. This is our equation number 1 by the first sentence. Let's talk about the second one. A different AP. So we'll have to separate it now. Has the first term P again, same. Okay, A1 is P. Common difference is 4, not 2 this time, so that means this will increase faster. The sum of the first Q terms, is 168. Find the values of P and Q. So we'll get one equation in terms of P and Q for this also. So we know the formula for Sn also, which is n over 2, 2a plus n minus 1 d. So I'll substitute it here. 168 is Sn, which will be n over 2. In this case, n is q. So q over 2. 2 times the first term. First term is p. 2p. And then we have plus n minus 1, which is q minus 1 in this case. And then we have d. d is 4. Alright, let's get rid of this 2 first by cross multiplying. 120 plus 16, 336 equal to q 2p plus 4q minus 4. Okay, can we do some? Yes, p is in terms of 16 minus 2q. So in place of this p, we will write 16 minus 2q, and that was good. It will be easy for us to substitute. So q It will be 16 minus 2q. No. We have to write this 2 also. So let's put it here, 2. 16 minus 2q plus 4q minus 4. So 336 equal to q, and 2 times 16 is 32, minus 4q, yeah, 2 times minus 2q is 4q, plus 4q, good, it will get cancelled out now, minus 4. So this and this get cancelled out, and the field is clear for us now. 336 equal to q, 32, and minus 4, 28. Divide both sides by 28. So q will be 28, okay, it will be 12. 336 divided by 28 is 12. So we had to find p as well, and we'll use this one. P is equal to 16 minus 2q. 2 times q is 12 now. So it becomes 16 minus 24, which is minus 8. This is the second answer. P and Q both, we are done. Question 11 is about this figure they have given. The diagram shows part of the line y equal to 1. This is y equal to 1. Let me complete this. Y equal to 1. This line is y equal to 1. That means this coordinate is 1, 0, 1. Okay. Okay. And the complete period of y equal to 1 plus cos x. This is the curve. Where x is in radians, the line PQ is tangent to the curve. PQ is tangent. That means, since I've drawn it myself, it is not that perfect. This curve is coming back, and that's why PQ is tangent at these two places. Alright, now the line QR is parallel to y-axis. We can see this is y-axis, PO is the y-axis. Okay, area A is enclosed by this line y equal to 1, and the curve, the black color area A. Area B is enclosed by y equal to 1, the line PQ up, and the curve. So this colored one, dark green colored, this bright green colored graph, this area is B. Okay, given that the area A ratio area B is 1 ratio K, that means area B is K times area A. That's what it means, right? And we can see it looks bigger. That means K's value should be more than 1. Okay, find the exact value of K. That's what we need to do. This question is worth 9 marks. So that means we have to do a lot of work. That's why I've copied it here. And what is my plan? Let me tell you my plan first. First step, I will find the area of this big rectangle, right? Then I will find the area under the curve from 0 till the end of this curve, till R. Okay, so this black colored, if I remove from the whole of the rectangle, I will get the area A plus B. B and A both, I will get their sum, right? That's the plan. So I will find this area first. Then what will I do? I'll find the area of this rectangle, which is here, where the y equal to 1 line is intersecting with the curve. I'll get the area of this particular rectangle, and again I will remove the same thing I will do with the smaller one. I'll remove this black area, so I'll get the area A only. So once I have the area of some A and B and only area A, I'll subtract, I'll get the area of B, and then I can find K very easily. So let's go to our first step, which was to find the area of this particular rectangle, which is OPQR. Area OPQR will be length times width, correct? So length is this from OR, which is OR multiplied by OP. Problem is we don't know what is OR, what is OP, but they've given it here. Y equal to cos x. Y equal to 1 plus cos x is the curve. So can we find when this y is 0 here? Isn't it y equal to 0 here? So if I find y equal to 0, I'll find this particular point. but I don't need this for OR and OP. But if I put y's maximum value, I'll get this thing. So what is the maximum value of y equal to 1 plus cos x? So maximum value is always the axis, which is 1, axis plus the amplitude. Amplitude is the coefficient of cos x. So 1 plus 1 is 2. 2 is the maximum value. This particular line is y equal to, they have not given it, but we found it logically. Let me try to explain this by some other means. This is the graph of cos x, normal cos x, 1 and minus 1, right? Cos x, this one. But if I add 1 to it, this whole graph goes up and becomes like this. This was minus 1, becomes 0, and this is how it graphs. So 1 kick went up, became 2. So we got y equal to 2 as this one. So we know that the starting point angle is 0. This is x is equal to 0. What is x here? X is equal to 2 pi. We know this very well from our previous classes. So we know OR now. OR is 2 pi. We know OP now, which is 2. So the area of OPQR we started, that rectangle is 2 pi times 2, which is 4 pi. This is the area of the whole rectangle, big rectangle. Now I have to subtract this area. And luckily, this area is under the curve between x-axis and the curve, so we don't have to do much in this, just integrate. So area under curve from 0 to 2 pi, right, will be integration from 0 to 2 pi 1 plus cos x dx. So integration of 1 is just x, integration of cos x is positive sin x and plus c. So from 0 to 2 pi, this will give us the area I have just mentioned. Okay, so I have to substitute 0 and 2 pi to get this area. Let me do it. So 2 pi plus sine 2 pi minus 0 plus sine 0 plus c, also we can write. C and c cancel first thing first. Alright, 2 pi is 2 pi. Sine 2 pi. So whenever we have such a situation of 0 pi and 2 pi, we can use the graph. So sine 2 pi we can see here is 0. This is the graph of sine. You can use your calculator also. So plus 0 minus 0, and sine 0 is also 0. So 2 pi is the area of this under curve, 2 pi. So area A plus area B will be the total area we got earlier of the rectangle 4 pi minus, we just got the area under curve 2 pi, which is 2 pi. The area of this A plus B, whole of it, is 2 pi. Now second stage, we have to find the same thing here also. This rectangle we'll find first. So we need to know these points. What is the length of this? Because we know the width is, this height is 1. Y equal to 1, so that means this is 1. Only thing left is these 2 points, and we go back to our cos graph and we can easily see that this is the point, these 2 points which went up and became y equal to 1 here. So this was pi by 2 in original cos graph, this was 3 pi by 2 in original cos graph. That means this one becomes pi by 2, this becomes 3 pi by 2, right? And that's what we are going to use here. So let's go back to smaller one. This is pi by 2, this is 3 pi by 2. If you can't use logic, you can use this one. The equation of the curve is 1 plus cos x, make it equal to 1, because this point and this point are the points of intersection of the curve 1 plus cos x and y equal to 1. So make it equal to 1, you'll get what? Cos x equal to 1 minus 1, cos x equal to 0, and if you write x equal to cos inverse 0, you will again use the graph and you can see that it is pi by 2 and 3 pi by 2. So logically, mathematically, any way you can do it. Now, area, let's give them some alphabets, right? Have we used ABCD? Nope. Okay. So let me put this point as A, B, C, and D. So area of the rectangle ABCD will be length. Length will be what? From pi by 2 to 3 pi by 2. So let me subtract pi by 2 from 3 pi by 2. We'll get this length from here to here. Height we already know is 1. And 3 pi by 2 minus pi by 2 is just pi. Pi times 1 is pi. This is the area of this whole rectangle, big rectangle. But the plan was that we have to subtract the area under curve from this whole rectangle. So we'll do the same thing what we did earlier, and we have already integrated, so we'll use the integrated part, x plus sine x plus c. This is what we will use to get that area. So area under curve, small curve, let's say small curve, smaller curve, will be x plus sine x plus c, but this time from pi by 2 to 3 pi by 2. So let's substitute 3 pi by 2 plus sine 3 pi by 2 plus c minus pi by 2 plus sine pi by 2 plus c. Cancel c and c. So 3 pi by 2 plus sine 3 pi by 2. Let's go to the graph again. You can use your calculator. I use graph. 3 pi by 2 in sine is here. This is 3 pi by 2. So it is minus 1. So let's go back to over here. It will be minus 1 minus pi by 2. And then sine pi by 2 is, according to the same graph, 1. But because of this minus, we'll write minus 1. So 3 pi by 2 minus pi by 2 is pi. Minus 1 is minus 2. This is the area under curve. This area we have to subtract from the area of the rectangle, smaller rectangle we got earlier. So area A only. This is what we'll get, right? Let me go back to the picture. Because we are subtracting this area from the area of this small rectangle, we'll get only area A. So area A will be pi minus, we got just now pi minus 2. So which is pi minus pi plus 2. Pi and pi cancel. So 2 units is the area A. Right? So we knew the area A plus B earlier. This 2 pi was area A plus area B. So we can get area B now. Area B will be the one we got 2 pi earlier, A plus B, and now we'll subtract the A from it. We get 2 pi minus 2. This is the area B. Now, they said area A ratio area B equal to 1 ratio K. Let me write this in fractional form, that will be easier to do. Area A ratio area B equal to 1 ratio K. And now we can find K easily. Area A is how much? 2. Area B, 2 pi minus 2 equal to 1 over K. We have to find K, so let's do cross multiplication. K goes there, but 2 will come down, cross multiply, and 2 pi minus 2 will go and multiply here. 2 pi minus 2 divided by 2. And now we have to separate them so that we can simplify 2 pi over 2 minus 2 over 2 and 2 cancel here, 2 and 2 cancel here. Finally, we get k equal to how much? Pi minus 1. That's the value of k, pi minus 1. Question number 12 and the last question. A curve is such that this is the condition, second derivative is this. Given that the gradient is dy over dx. So read this as given that the dy over dx of the curve is 4 over 3 at the point, that means when x is equal to 1 and y is equal to minus 1. That's how we interpret this. Find the equation of the curve. Find the equation of the curve means y equal to what? That's the expression we need. Now, since this is the second derivative, we have to go to the first derivative so that we can substitute these numbers. So we have to integrate d square y over dx square with respect to dx and also the right side, which is square root x plus 1 over fourth root of x. It is not 4 square root x, okay? It is fourth root of x square dx. Okay, so the integration of second derivative is the first derivative, which is di over dx, will be equal to the integration of this. This looks complicated, but if you look very carefully, this square will cancel out this fourth root to some extent and it will make our job easier. So let's separate the two. Square root x plus 1 square over fourth root I'm writing as x to the power 1/4. Okay, is the same thing, square. So this square is applied to both numerator and denominator. That's possible with exponents, we can do that. So dy over dx is equal to, and let's expand this one. I'll again use the same identity I used in one of the previous questions, a plus b square, which is a square plus b square plus 2ab. So a square plus b square plus 2ab. Okay, divide by, now this is exponent of an exponent, they multiply, so 1/4 times 2 will be 1/2. Okay, and dx. So x to the power 1/2 is actually square root x. I'm not writing it right now because this may be helpful later. Dy over dx equal to square root and square cancel. So we have not integrated yet, so we have to write this integration sign. X plus 1 square is 1 plus 2 square root x divided by x to the power half, or let's write it square root x because I want to cancel this dx. Okay, let's complete it here. Dy over dx will be integration of, I'm separating the numerators so that I get individual terms. So x divided by square root x plus 1 over square root x plus 2 square root x over square root x and whole of it dx. Okay, dy over dx is equal to x divided by square root x is square root x. Or let me write it the other way. Square root x I will write as x to the power half. Because x is power 1, this is power half, and 1 minus half is half. That's how it comes out to be. This 1 over square root x can be written as x to the power minus half. And this square root x and this square root x cancel, we get plus 2, and they are integrated. Now we'll carry out the integration because it is easy to integrate them. X to the power half, its integration will be x to the power half plus 1 divided by half plus 1. Similarly here, x to the power minus half plus 1 over minus half plus 1. And here it will be 2x plus some constant c. Okay, so what do we get here? dy over dx equal to x to the power 3 over 2 divided by 3 over 2. So I will just write 3 here and 2 here. We can write denominator of a denominator becomes numerator. Similarly here, x to the power positive half and divided by 1 over 2, but I will write 2 here and no need to write 1 at the denominator. Plus 2x plus c. We have got the equation for the first derivative, which is gradient. Now, they said gradient is how much? 4 over 3? 4 over 3 when x is 1. So I'll substitute here. Dy over dx is 4 over 3 when x is 1. In this equation, we'll substitute these numbers. 4 over 3 equal to 2 over 3, and I'm not doing anything because 1 to the power anything is 1. So no need to substitute here. I'm just leaving it like this. Similarly, in the other one, it will be plus 2. Next, it will be plus 2 plus c. Keep the c to the right side, and 4 over 3 minus 2 over 3 will be, okay, let me write all of them. Minus 2 over 3, minus 2, minus 2. All of them went to the left side. So it will be minus 4, minus 12, minus 14, plus 4. You can use your calculator. I'm doing mental math. 10 over 3 I got as C. So the equation of the gradient dy over dx becomes 2 over 3x 3 over 2 plus 2 square root x plus 2x, and we got C as negative 10 over 3. But the question was not about gradient. Question was find the equation of the curve. That means we have to integrate once more to get y. So we will again integrate dy over dx with respect to x, and we will integrate here also 2 over 3 x to the power 3 over 2 plus 2x to the power half. For integration, it is better to write this way: 2x minus 10 over 3 dx. Okay, so the integration of the first derivative is just y. That's what we want. Here 2 over 3 remains 2 over 3 because it is constant, but here the exponent will still go up by 1 and it will be divided by the same. Here 2 remains 2, x to the power half plus 1 over half plus 1, 2x to the power 1 plus 1 over 1 plus 1 minus 10 over 3. There is no x, so we'll add x here, and that becomes the integration. This time I'm writing the constant d. Okay, right, let's simplify. Y equal to 2 over 3x to the power 5 over 2 divided by 5, and let's write 2 here multiplied by 2 plus 2x to the power 3 over 2 over 3 over 2. It's multiplying. Plus 2x square over 2 minus 10 over 3x plus d. This 2 and this 2 can cancel. Alright. Now, they said when x is 1, y is negative 1 as far as I remember. Yes. Yeah? So we'll use this to get the final equation. We'll substitute this here. Y is minus 1 equal to, it becomes 4 over 15. And again, 1 to the power 5 over 2 is again 1. So there is no need to write anything about x. Whenever x is equal to 1, that is the easiest situation you can have. Plus 4 over 3. Here x squared is just 1. Minus 10 over 3. And plus d. Now we have to find d, keep the d on the right side, and everything goes here. Minus 1 minus 4 over 15 minus 4 over 3 minus 1 plus 10 over 3 is d. Their LCM comes out to be 15. So this will be minus 15 minus 4, 4 times 5, 20, minus 15 and 10 times 5, 50 equal to D. 15, 20, 35, 50, though they are negative, they cancel with this positive 50. So we are left with only negative 4 over 15, which is D. So what is our final equation now? Let me write here. Our final equation will be from here, which will be y equal to 4 over 15 x to the power 5 over 2 plus 4 over 3 x to the power 3 over 2 plus x square minus 10 over 3x, and finally we have d equal to minus 4 over 15. Voila, we have finished the whole exam with this answer.